Hello students. Now in this lecture we are going to see the methods of preparation of aldehydes and ketones, and after that methods of preparation of carboxylic acids. First we will see the preparation of aldehyde. The first preparation in our textbook is given from acid chloride. Okay, this acid chloride is nothing but acid chloride. Okay, and this is naming reaction. Naming reaction means reaction is like this Rosenmund is the name of the scientist who find out this reaction and who prepared aldehyde. That's why the name of the reaction is Rosenmund reduction reaction. This is the reduction process. So this is the reduction reaction. Okay, and the name of the scientist who search or research this reaction is Rosenmund. Okay, now what he used? He used acyl chloride, which is reduced to corresponding aldehyde by hydrogen using palladium catalyst. Okay, so palladium catalyst in presence of barium sulfate. This is again important. You have to write down H2 palladium present in barium sulfate. Now here it is. We studied some few reactions like hydrogenation. There is the nickel, palladium, platinum we used. But now the important thing is that when barium sulfate is there, then this gives you reduction. This gives you reduction. This is not hydrogenation reaction. This is very important. Okay. You just remember the previous reactions which we studied in 11th standard as well as 12th standard. We use H2 in presence of nickel, platinum or palladium, then that is hydrogenation reaction. But now this is here reduction reaction. And what is that? This acyl chloride is reduced to aldehyde. Acid chloride is reduced to aldehyde. Now why this is we call acyl chloride? We know the acetic acid. What is that? CH3 C double bond O OH. And from this group is known as acyl group. And instead of OH, when there is a chlorine attached, then this is known as acyl chloride. So this is general reaction when we are using R. When we are using some specific methyl group, then this is our example. So here we use CH3 C double bond OCl, and then we get here CH3 C double bond OH. Byproduct is HCl, and that is acetaldehyde. Okay, means what? This H2 HH. Okay, this chlorine is replaced by H, and this H is reacting with this chlorine and we get HCl. This is the byproduct. This is very easy reaction to understand and to remember. But important thing is that when you are studying chemical reactions in organic chemistry, you have to do practice. Okay. Make sure that each and every reaction you are going to write 5 times for your revision. So then and then only this will fit in your mind, and you can write by knowing the reactant. You have to know the product by using specific reagents. Okay, that's why you have to write the reactions and make perfect pattern of the reactions. That is reactant reacting with some reagents or in presence of some reagents and gives you product. Okay, next, this is again very important reaction and something very important in the way, like we are going to use the Grignard reagent. Short form is GR. General presentation is RMGX. RMGX means alkyl halide, and in between that there is a magnesium. This is known as Grignard reagent, RMGX. So what is this reaction? Preparation of ketone from acyl chloride by reaction with dialkyl cadmium. This is again important. This is something new for you. Dialkyl cadmium, which is prepared by the treatment of cadmium chloride with Grignard reagent. Dialkyl cadmium. This dialkyl cadmium is prepared by the treatment of cadmium chloride with Grignard reagent. Means this Grignard reagent we use in first step. to get dialkyl cadmium from cadmium chloride. And then after preparing this dialkyl cadmium, we are going to treat it with RCOCl, that is acyl chloride, and it is converted into ketone. And byproduct is cadmium chloride. So what is this reaction? See, there are two steps. Step 1, this RMgX means our Grignard reagent, okay, reacting with cadmium chloride gives you dialkyl cadmium, R2. So this is dialkyl and cadmium is there, so this is dialkyl cadmium. And what is the byproduct? Byproduct is twice MgXCl. You can write like this also, or you may write like this also, both the way it is same. MgX, Mg bond X, Mg bond Cl, and these are the two molecules, so we are writing here 2. Okay, now what is step 2? We started with the acyl chloride, so here also the acyl chloride. Now this R2CD which we prepared in the first step is going to react with this, and this is converted into ketone. What is this? R dash COR means what is this? This is nothing but R dash C double bond O R. This is our ketone. R dash C double bond O R. R dash and R may be same or different. So this is our ketone. Okay. And here it is, byproduct is cadmium chloride. Now by taking R, we generalize this reaction. Now taking a specific alkyl group, we can write the examples. So this is methyl magnesium bromide reacting with cadmium chloride to give you dimethyl cadmium. This dimethyl cadmium is going to react with the acyl chloride, which gives you acetone. Both R groups are the same, and so this is cadmium chloride. And this is our previously, this is dimethyl cadmium, which is like this: cadmium CH3 twice, CH3 CD. So this is a condensed formula we are writing. Actually molecular formula is like this: CH3. Then next, again you can take this cadmium chloride treated with CH3 MgBr. This is the first thing we prepared, dimethyl cadmium. Then this dimethyl cadmium is going to react with ethyl COCl. Okay, this is C2H5COCl. Okay, and then when we are going to write here CH3, then this one is 2 carbons are here, 1 carbon is here, 1 carbon is here, means totally 2 plus 3 plus 4 carbons total. So this is butanone. Okay, and now if you are going to write a IUPAC name, then you have to mention the number of carbonyl carbon. So this is 1 and 2, so you can write but 1 2. Now this E is replaced by ONE, so this is butanone. Okay, so butanone you can write like this, or IUPAC nomenclature like this. So final product is CdCl2, and the final product is ClCl2. All these are the byproducts, and the main product is our preparation of ketone. Okay, next, preparation of now aromatic ketones. Initially we studied preparation of aliphatic ketones. Now preparation of aromatic ketones from nitriles. Cyanides are also called as nitriles. We studied this thing in 11th standard. Okay. Now what is this? This reaction is called Stephan reaction. Again, this is the name in reaction. Name of the scientist is Stephan. So this is Stephan reaction. Okay. Nitriles are reduced to corresponding imine. This is something new again. This is the 12th standard. We have to study something higher than 11th standard, and this is the imine hydrochloride by stannous chloride. This stannous is also known as tin. in presence of hydrochloric acid, which on hydrolysis gives corresponding aldehyde. Means what? This is again the two-step reaction. In a first step reaction, this is the nascent hydrogen. So this gives you, here it is reduction reaction, and this alkane nitrile C triple bonds N. So nitrile or cyanide is treated with two nascent hydrogens in presence of stannous chloride or tin chloride in with hydrochloric acid. Then what is going to happen? This triple bond is converted into double bond. Okay, here are two hydrogens, one hydrogen attached to this carbon, this one hydrogen, this H and H like this, and then another hydrogen is attached to this N and HCl is along with that. Okay, and when such a product is there, means double bond and nitrogen, then this is known as imine. This is known as imine, and there is HCl, so this is imine hydrochloride. Means this one is our imine. Okay, RHC double bond NH, this is our imine, and HCl is there, so this is hydrochloride. Next step is hydrolysis. And this is acid hydrolysis. When we are mentioning acid hydrolysis, means what? Addition of water molecule in presence of acid, and this is also known as hydronium ion. This is also H3O positive is also known as hydronium ion. Okay, so what is going to happen over here? See, this RHC, okay, this is going to react with here H3O. There is a formation of RCHO. What is now remaining? N is remaining, H is remaining, and then there are the hydrogens are there. So we are adding here, this one hydrogen is here, two hydrogens from this. So this is NH4Cl. Okay, so this is our aldehyde preparation. Okay, then actually here should be not only aromatic ketones, but here should be aldehydes and ketones. Preparation of aromatic aldehydes and ketone. First we will see aldehyde, then we will see ketones. Okay, so this is C6 RCHO NH4Cl. Now if we start with benzonitrile C6H5 C triple bond N, now we can prepare aromatic aldehyde. So this is C6H5CHO, this is benzaldehyde, byproduct is NH4Cl. Okay, you can write one more example which is given in our textbook as a homework. Write it down in a 2 steps. Okay, and tell me the product in the comment box. Okay, in the comment box write down the product of this reaction. Take this reaction as a homework. What is over here? Then here it is H3O positive, and what is the product? So this is a 2-step reaction. This is product A, this is product B, like that. Then alternate method is there. One more alternate method is there. Starting with the alkane nitrile by using stannous chloride, this is one of the method. Then the hydrolysis, acid hydrolysis, and another alternate method is by using diisobutyl aluminium hydride. Short form for di D, for iso I, for butyl B, for aluminium Al, and then hydride H. Diisobutyl aluminium hydride. This is one of the reagent, or you may use aluminium hydride also, and there is acid hydrolysis. Then what is going to happen? Just like this, here it is C triple bond N is converted into CHO. Same way here it is the conversion of the CHO. See, for understanding, you have to write down the two steps over here, and then that means first reaction with diisobutyl aluminum hydride, and then the reaction with H3O, you get this aldehyde. So for the shortcut, I wrote over here both the reagents on the same arrow and shown you reactant converted into product. This is one of the method. Then next one is preparation of ketones from nitriles. First we prepare aldehydes. Now we are going to prepare ketones from nitriles. Ketones are prepared by reacting nitriles with Grignard reagent in dry ether. This is very important as solvent, followed by acid hydrolysis. This is again two-step reaction. This is again two-step reaction. Okay, by acid hydrolysis. Okay, so see now what is given. Ketones are prepared by reacting nitriles with Grignard reagent in dry ether as solvent. Dry ether as solvent, followed by acid hydrolysis. Okay, followed by acid hydrolysis. Now see here, this is our nitrile. This is our nitrile. Here it is H3C C triple bond and aliphatic nitrile, ethane nitrile. This is treated with Grignard reagent. This Grignard reagent in dry ether. So I am writing here dry ether as a solvent. So what is the product now? See here. Here it is CH3. This is CH3 here, Mg here, Cl here. Okay. So now this CH3 is going to attach to this carbon. So there is formation of CH3CCH3 like this. Okay. Now this triple bond is converted into double bond. This converted into double bond. N is there. N is there. Then this MgCl attached to this N. MgCl attached to this N. So this thing had happened. Okay. Here it is the hydrolysis, and in our book they directly get this ketone. This is ammonia and MgClOH, but this reaction is not balanced, which is given in a textbook. So I did it in a different steps. Okay, what is that? This CH3C CH3 double bond and MgCl is undergoing hydrolysis, acid hydrolysis. So what is going to happen? Okay, see now here, CH3C CH3 double bond NH, from this H2O, like HOH, one of the H is attached over here and one OH is attached to this Mg. This H plus represent acid hydrolysis. This represent acid. So in a reaction, this H2O is taking part and there is MgOH, MgCl. This is somewhat difficult to understand, but try to understand. In our book we are not clear cut knowing this, how the byproducts are getting. That's why I am writing in a simple form. Okay, repeat this reaction 4-5 times, you can understand this very well. This HOH, from this one H is attached here, and to this Mg one OH, this OH, and Cl is there. So Cl is there. Now this is the complex. This one is complex. So now it has to stabilize. Then again next hydrolysis takes place and there is formation of CH3C CH3 double bond O. Now what is the byproduct? Byproduct is ammonia. So from here, now here, this is here, see, this is HOH. Okay, and now here one more hydrolysis, there is a one more H plus is there. Byproduct formation is the NH3, and then here remaining is MgOHCl. This MgOHCl is here. This is coming here, MgOHCl. From here, here this O is going to attach over here. Then this NH and these two hydrogens, this become NH3. Okay, this O attached over here, and then this NH and these two hydrogens become NH3. This MgOHCl is there in a second step, that is carry forward over here. Okay, so please try to understand this thing, how we get NH3 ammonia and this byproduct, and this is the ketone. This is now our aliphatic ketone. Okay, now we are going to see aromatic ketones. We are going to see aromatic ketones. Okay, and for that we have to take reactant as a aromatic nitrile. Reactant as a aromatic nitrile, and this is our benzonitrile. Means what? On the benzene ring there is C triple bond N, benzonitrile. Then here again we used aromatic Grignard reagent. Instead of R, now there is benzene ring. This is benzene ring. So this is our ARMGBR. Are you getting this thing? Okay. Here we used CH3MgCl. This is aliphatic Grignard reagent. Now we are using here aromatic Grignard reagent. Solvent is same, that is dry ether. Same just like this. The first step over here. Here it is the first step. Same the step over here. Only now here it is CH3 instead of there is two aromatic rings, two benzene rings. Okay. Again for the simplification, I am using these two steps. Just like here NH is formed, here also double bond NH is formed. Then again H2O, instead of this NO comes over here. This NH with this H2, there is formation of NH3. And the aromatic ketone we get, that is benzophenone. This is benzophenone. Two benzene rings attached to carbonyl carbon. So this is known as benzophenone. This is ketone. One ring mentioned as a benzo, another ring mentioned as a phenyl ring, and then the name is benzophenone. Okay, please make your own notes, take a screenshots or go this recording one by one, make your own notes so you can understand how the reactant is converted to the product in different steps and how we get the final product. Similarly, how we will get here the final product. Make your own notes, okay, from this video. This is most important for you to study. Then next thing, see here, preparation of now aromatic aldehydes from hydrocarbons. Preparation of aromatic aldehydes from hydrocarbons. Now this is again somewhat difficult reaction, but I try to make it simple. Okay, aldehyde and ketones both are prepared from aromatic hydrocarbons by different methods. Methods are not same. In the previous case, methods are same. Methods are same. Grignard reagent, there is aliphatic Grignard reagent. When you want to aromatic, then there is aromatic Grignard reagent, and starting with the aromatic compound, starting with the aliphatic compound, you get the aldehyde and ketones. But now here different are the different methods for obtaining aromatic aldehyde from methyl arene. The following special methods are used. Methyl arene is nothing but toluene. Methyl arene is nothing but toluene. This is our methyl group, and to this methyl group there is a arene, means benzene ring. Okay, so this is known as toluene. This is known as toluene, or this is known as methyl arene. So now this toluene react with chromyl chloride, CrO2Cl2 is known as chromyl chloride, and forms chromium complex. This forms chromium complex, which on acidic hydrolysis gives corresponding aldehyde, that means benzaldehyde. This is aromatic aldehyde. And again this is the naming reaction, name reaction. Name of the scientist is Etard. Name of the scientist is Etard, E-T-E-A-R-D, Etard. Name of the scientist is Etard, and he gave us the way or the steps to get prepared to get benzaldehyde. Okay, now see what is the reaction. Here it is toluene. We can write it separately like this. Actually the toluene is like this. We can write CH3 here, but for the understanding we are writing now these are three separate hydrogens. Okay, then this is reacting with the chromyl chloride. This is CrO2Cl2, chromyl chloride. Okay, then in presence of carbon disulfide. In presence of carbon disulfide. This is very important. You have to write this carbon disulfide. Without that, this reaction is not going to proceed further. Or you may write non-polar solvent like CCl4. This is important. Okay. And this reaction is the partial oxidation. This reaction is partial oxidation. This is not total oxidation. This is partial oxidation. When there is a complete total oxidation, then that is reaction is like this. Complete oxidation is like this. This toluene reacting with KMnO4 converted into potassium salt of benzoic acid. Again hydrolysis, it gives you benzoic acid. This is complete oxidation. But while in a partial oxidation, we get aldehyde. We get aldehyde, this benzaldehyde product. So what is going to happen? See here. This is CrO2Cl2. These are the two molecules of the chromyl chloride. Okay. Now at this position H, okay, and at this position H, this is going to attach. CrO2Cl2 is going to attach, but it attach in this form. One O comes over here like this. Then this chromium is there. Okay, chromium is there. From this 2O, 1 O is here, so 1 O is remaining, and this H attached to this. So there is formation of OH, and Cl2 remain as it is. Here it is Cl2 remain as it is. Are you getting this thing? See how we arrange this. This O2 we arrange separately. Two oxygens. The position is now the different. Okay. And this H is with another oxygen, so there is formation of OHCl2. Similarly, with this hydrogen, this is going to react and there is a formation of such type of complex. Okay. Now see, when it undergoes hydrolysis, what is going to happen? Already this C is having H. Means to get aldehyde, we only want one oxygen. We only want one oxygen. So what is this here? Here it is H2O, H plus, hydronium ion. So one of the oxygen is here, and means, and then there is OH. Then there is OH. That OH, see here OO is there. So one of the oxygen is there, and then here formation of byproduct as chromium OH twice Cl2. This O will get one of the H from here. This is HOH. One of the H from here. O attach here. So this O is again become OH. And so one OH, this another OH like this. And here it is formation of OH2. Are you getting this thing? HOH. O attach over here. CH. See here. This is CHO, then this O attached to this, there is formation of CHO, and byproduct is twice CrOH twice Cl2. This is not given in our textbook, and so somewhat confusion is there. So make sure you can write this byproduct in the textbook, and when you are going to do practice, when you are going to learn this reaction, be sure that you are going to write this byproduct here, so you are not going to confuse where all things are gone, how this oxygen is here, what happened with this. Okay, that's why simplified reaction is like this. Okay, when you are going to do practice, when you are going to write 5 to 10 times this reaction, you can understand it very easily. This is the byproduct which is not given in the textbook. So what happened is given clearly. So please try to understand. If you are any doubt, please write down in a comment box. I am going to explain again. Okay, if there any problem. Next reaction is by oxidation of methylarine using CrO3. This is our chromyl oxide. This is our chromyl oxide, or you may say chromium oxide. Okay, CrO3. Methylarine is our toluene, is converted into benzaldene diacetate on treatment with chromium oxide. What is this? Benzaldene diacetate. This is our benzaldene diacetate. This is benzaldene diacetate. Okay, benzaldene diacetate on treatment with chromium oxide in acetic anhydride. Temperature is given and the diacetate derivative on acid hydrolysis gives you corresponding aldehyde. This is acetate derivative on hydrolysis gives you corresponding aldehyde. Okay, this chromium oxide, in chromium oxide we should write on the arrow also. Not necessary to write this oxidizing agent in a reaction matter because we are not going to write in the product. This is just an oxidizing agent which gives us nascent hydrogen for oxidation. So we can write this oxidizing agent chromic oxide on this arrow, that is much more easy. Don't write over here. Okay, and this is acetic anhydride. In 11th standard also I explained what is acetic anhydride. Do you remember that what is acetic anhydride? See now, here it is CH3 C double bond OH. What is this? This is acetic acid, another molecule of acetic acid like this. And when we are going to remove one water molecule from this, means we are going to do anhydride product, then this is CH3 C double bond O C double bond O CH3, and this is our acetic anhydride. This is our acetic anhydride. I see here, this is C double bond O, we can write it like this, or C double bond O, we can write it like this. Okay, so what is going to happen? Just like the previous reaction, these two H, similarly here these two H are going to react with acetic anhydride, and that is OCOCH3. OCOCH3. One nascent oxygen is there, so that is again going to react with here OCOCH3. This is OCOCH3. Okay, and here it is again O, this nascent oxygen, so there is again formation of OCOCH3. See here, if you are going to break the bond like this, so there is CH3COO, here it is CH3COO, then this oxygen is with this, so this is CH3COO. So this is our benzylidene diacetate. This is undergo hydrolysis reaction, there is formation of CHO. Means what? One of the oxygen is now attached over here, CHO. Now remaining H and H is there. They are going to react with here C, and there is a formation of COOH. This COOH. COOH. So there is formation of two molecules of acetic acid. Two molecules of acetic acid. What is this? Toluene reacting with acetic anhydride in presence of chromic oxide, means this is a oxidizing agent. This is oxidizing agent. Oxidation takes place. Product is benzylidene diacetate. Undergo acid hydrolysis. We get benzaldehyde, means aromatic aldehyde, and byproduct is acetic acid. Byproduct is acetic acid. Okay. Next, by side chain chlorination of toluene, we are going to get aldehyde. By side chain chlorination means this side chain is undergo chlorination and we get aldehyde. This is one of the commercial method where we get a very good yield. Then that reaction is known as commercial method. The product quantity is high. So this is commercial method, and reaction is very neat. No complications, no complex formation, no much more byproducts, only simple byproduct. Then such type of reactions are called as a commercial methods. Okay. So here toluene gives benzyl chloride, which on acid hydrolysis at 373 Kelvin gives you benzaldehyde, and this is commercial method of manufacturing of benzaldehyde. This is our benzaldehyde. So what is going to happen here? Chlorination of the side chain. This is our side chain. Chlorination. We know chlorination takes place in diffuse light or in sunlight. So we mention here H nu. So from this CH3, two hydrogens are replaced by chlorine. This is a simple chlorination reaction. CH4, do you remember in 11th standard in a hydrocarbon alkane chapter, CH4 converted into CH3Cl. Then it is converted into CHCl2. Then it is converted into CHCl3. Then it is converted into CCl4. Same way, CH3 from these two hydrogens are replaced by chlorine. This is the chlorination. And then on hydrolysis, these two chlorine, one of the oxygen attached over here, that is the CHO, H2OH, and then this is the H, means the acidic condition, and these remaining two H are going to attach to this chlorine. So there is the formation of twice HCl. Okay. In the reaction mixture, hydrolysis is addition of hydrogen molecule only, and then here is 2HCl reacting with this, oxygen is attached over here. Already we have here CH. This Cl2 is converted into hydrochloric acid. Okay, this is known as commercial method of manufacturing benzaldehyde. Why commercial method? I explained this before. This is very neat and clean reaction. Very simple byproduct. Temperature is also moderate. Chlorination in presence of diffuse sunlight or sunlight. So we are writing ultraviolet light. So we are writing here H nu. Again, this is a simple reaction, and that's why this is commercial method. Next one is Gattermann-Koch formylation of arene. This is again the naming reaction. This is the name of the scientist. Now it gives formylation, means when there is a aldehydic group attachment is known as formylation, because we know that HCHO is our formaldehyde. HCHO is our formaldehyde, and when that CHO group is attached means this is formylation. Benzene or substituted benzene, means benzene or some another substituent is here, treated under high pressure. Under high pressure, see here I am written over here high pressure, this high pressure with carbon monoxide. This is very important. In Gattermann-Koch, what we use carbon monoxide. You have to remember this way. GK use CO, GK use CO, Gattermann-Koch use carbon monoxide. Remember in this way, so you can remember if in the form of short form, then you can understand what is the reagent for that. Okay, so this is carbon monoxide and hydrogen chloride in presence of anhydrous AlCl3, or this is cuprous chloride to give benzaldehyde or substituted benzaldehyde. Substituted means if here it is the chlorine, then this is the substituted benzene, and when with this chlorine we get this product, then this is substituted benzaldehyde. Reagents are the same. This is benzene, this is substituted benzene. Okay, carbon monoxide HCl, anhydrous or the cuprous chloride, high pressure, and here it is benzaldehyde, while this product is 2-chlorobenzaldehyde. So by side chain chlorination of toluene, then we studied Gattermann-Koch formulation of arene. We get benzaldehyde. Here also we get benzaldehyde. Here also we get benzaldehyde. This is our substituted benzaldehyde. Okay. And now the last reaction of this lecture is preparation of aromatic ketones from hydrocarbons. Okay. And this we studied in chapter 12th also, in 12th standard, and in chapter 15th in 11th standard also. These are the sections given and these are the reactions. These are that reactions. Friedel-Crafts acylation reaction. This is aromatic hydrocarbon which is a benzene. Okay. And when there is acylation, then we get this is aromatic ketone. Aromatic ketone. Or you are going to use suppose acid anhydride, in presence of anhydrous Al3 you are also get aromatic ketone. This is Friedel-Crafts acylation reaction. We studied in 11th standard in aromatic compounds. Friedel-Crafts acylation reaction. Byproduct is HCl here, while byproduct here it is acetic acid. Okay. So, in our textbook, in a short way this is given, you have to revise it, and that is why I have shown these two reactions which we studied before. Okay. So, I am not going to waste much more time on this because we studied it before. Then next one is preparation of aldehydes only from esters. This is again important reaction. Ester, RC double bond OR dash is ester. RC double bond OR dash is ester, and from this is our ester functional group. Dash C double bond OR dash is a ester functional group. So, what is that reaction? Aliphatic or aromatic esters are reduced. See the word reduced to aldehyde by using diisobutyl aluminum hydride, which we studied first. This is diisobutyl aluminum hydride, or we can write as aluminum hydride first, then I stands for iso, this is bu stands for butyl, and di stands for this 2. We can write DiBALH like this also, ALHIBU2, we can write it like this also. And the reaction is usually carried out at 195 Kelvin. This is very specific temperature to prevent further reduction, because this is the reducing agent. We don't want further reduction. That's why we have to stop here aldehyde. We don't want to convert it into benzoic acid. That's why we use this reducing agent here to prevent further reduction, and temperature is also moderate, that is 195 Kelvin. Okay. So, here this is RCOOR dash, reducing agent we use converted into aldehyde. If the further reduction is there, then aldehyde is converted into alcohol, not into acid, converted into alcohol. RCOH converted into alcohol. This is the reduction reaction. Okay. So, up till now we studied methods of preparation of aldehyde and ketones. Now, the remaining is methods of preparation of carboxylic acids. So, in the next lecture we are going to see methods of preparation of carboxylic acids. Thank you.